What if your mind is not your own? Imagine every thought, feeling, idea is not confined to your brain. Picture a universe where these experiences are threads woven into a cosmic tapestry. This web of connections stretches across space, linking minds across time itself. Is the boundary between ourselves and the universe an illusion? We stand on the precipice of a new understanding, challenging everything we believe about who we are. What if our awareness is not just biology, but a phenomenon born from the cosmos' mysterious rules? This is quantum mechanics, a world that may hold the key to consciousness itself. It asks us to consider a possibility, that consciousness might be a fundamental property of reality. Is the mind a gateway to the cosmos? The implications are staggering, forcing us to reconsider our place in the universe. We may be active participants, entangled with the very fabric of existence. At first glance, our minds feel intensely private, a sanctuary inaccessible to anyone else. Yet what if this feeling of isolation is not the whole story? Emerging research suggests that our individual consciousness might be a local ripple of a much larger interconnected system. Within every neuron, there are microscopic protein tubes known as microtubules. A daring framework proposes that something extraordinary is happening within them. An astonishing quantum trick called entanglement. They could be dynamic quantum information carriers, constantly exchanging and entangling signals. If this is true, it shakes the very foundations of what we assume about brain activity. This concept opens a door to a new reality. A reality where our consciousness is tied into the quantum nature of the universe itself. There, within the echoes of our own minds, we may find the ultimate connection. To grasp this radical idea, we must first journey into the bewildering world of quantum mechanics. It is a world where the rules of our everyday reality no longer apply. At the heart of this strangeness lies quantum entanglement. Imagine two particles forever linked. No matter how far you separate them, their fates remain intertwined. This connection is instantaneous. This troubled Albert Einstein, who called it spooky action at a distance. Decade after decade of experiments have proven him wrong. This bizarre property is now the engine behind some of humanity's most groundbreaking technological pursuits, like quantum computers. How does our awareness fit into the quantum picture? The idea that consciousness might be rooted in quantum mechanics was brought into the scientific arena by Sir Roger Penrose and anesthesiologist Stuart Hameroff. They proposed the OR theory, suggesting consciousness is a sequence of discrete moments born from quantum events within brain neuron microtubules. Quantum superpositions build up until they reach a critical threshold, collapsing into a single reality, a moment of conscious awareness. This suggests every instant of experience is a physical event governed by quantum mechanics, a fundamental event in space-time. Awareness moments could be entangled across the universe. Anesthetics might work by scrambling quantum signals, preventing collapse and shutting down conscious experience. For a long time, the OR theory was seen as compelling, but speculative, lacking the hard experimental evidence needed to convince a skeptical scientific community. However, recent findings have begun to provide tantalizing hints that Penrose and Hameroff might be onto something profound. One of the most intriguing pieces of the puzzle comes from the very field that inspired the theory anesthesia. If anesthetics work by disrupting quantum events in microtubules, then protecting those microtubules should make an animal more resistant to the drugs. This is exactly what neuroscientist Mike Wiest and his team set out to test. In a landmark study, they worked with rats, a common model for studying brain function. One group of rats was given a drug known to stabilize and protect microtubules, reinforcing their structure. Another group was left untreated. Both groups were then exposed to anesthetic gas. The results were striking. The rats with the stabilized microtubules stayed awake significantly longer under anesthesia than the untreated animals. It was as if their consciousness had a stronger anchor, one that was harder for the anesthetic to dislodge. The implication is powerful. The microtubules appear to be playing a direct and crucial role in maintaining the conscious state. This finding directly supports the quantum hypothesis. While it doesn't offer definitive proof, it strongly suggests that the anesthetic isn't just acting on neuron surfaces or neurotransmitters in the classical sense. Instead, it seems to be targeting these deeper intracellular structures. The gas molecules may be interfering with the delicate quantum computations that the OR theory predicts are happening within the microtubules. By scrambling these fragile quantum signals, the anesthetic effectively prevents the orchestrated collapse, that gives rise to conscious moments, causing awareness to fade into darkness until the gas wears off and the quantum symphony can resume. These whispers of experimental proof are sending ripples through the fields of neuroscience and physics. They are forcing researchers to take a second look at ideas that were once dismissed as too speculative. The study with the rats is just one piece of a growing body of evidence. Other experiments are beginning to challenge the long-held assumption that the brain is too warm and wet to support fragile quantum phenomena. As each new piece of data comes to light, the radical notion that consciousness is a quantum process becomes a little less spooky and a little more like a scientific revolution waiting to happen. For decades, a barrier has stood in the way of any quantum theory of consciousness. Critics say the brain is a warm, wet, and chaotic environment, a biological swamp, teeming with electrical noise. In quantum physics, coherence is fragile. Even the slightest disturbance can cause this state to collapse. How could any delicate quantum state possibly survive long enough to perform a meaningful computation inside a neuron? Yet nature is full of surprises. Recent evidence is beginning to dismantle this long-standing objection. A groundbreaking MRI study found that some of the deepest regions of the brain can operate at temperatures well above 104 degrees Fahrenheit. What if the brain isn't a swamp that destroys quantum states, but an incubator designed to protect them? Physicists are now demonstrating how quantum coherence might not only survive but thrive within biological structures. A study suggested that the myelin sheaths could act like tiny biological cavities, turning the brain's own wiring into a source of quantum connection. Nature has long used quantum mechanics, most notably in photosynthesis. Plants convert sunlight to energy with over 95% efficiency, a feat classical physics can't explain. The secret? Quantum coherence. Energy travels as a wave, exploring all paths at once, instantly finding the most efficient route. This quantum search is biology's way of harnessing the subatomic world for survival. Recent research shows quantum effects aren't limited to plants. In the human brain, microtubules may sustain quantum coherence for nanoseconds, an eternity at that scale. These structures could shield quantum states, acting as natural quantum conduits. If true, our brains might use quantum tricks for processing information, just as plants do for energy. This could explain the brain's remarkable power and efficiency. It suggests our minds are not just classical machines, but hybrid quantum biological systems. The implications for understanding consciousness are profound. Quantum mechanics may offer a new lens on how our brains work. Billions of neurons fire every second, but classical signaling is slow. What if the brain uses quantum entanglement for instant communication across regions? Entangled neurons could synchronize activity instantly, bypassing slow chemical signals. This might explain the brain's speed in tasks like catching a ball, integrating sensory and motor data in a flash. Quantum shortcuts could underlie our rapid, flexible thinking. Classical processes still matter, but a hidden quantum layer may handle complex computations. This dual system could make the brain a uniquely powerful processor. The speed of thought may be rooted in the universe's most mysterious laws. Our brains might be the ultimate quantum machines. Not all scientists are convinced by the quantum brain hypothesis. Skeptics argue that classical neuroscience can explain consciousness without invoking quantum mechanics. The brain's complexity alone, with billions of neurons, may be enough. Anesthesia experiments and microtubule findings could have classical explanations. Consciousness is robust, persisting through noise and change, traits of classical systems. Quantum states are fragile. Evolution may favor reliability over risk. Critics demand direct evidence that quantum effects are essential for consciousness. They urge caution, insisting on exhausting classical explanations first. This skepticism keeps the debate grounded in scientific rigor. The burden of proof remains high for quantum mind theories. The challenge is finding definitive proof that quantum events drive consciousness. Quantum and classical processes are deeply intertwined in the brain, making them hard to separate. Observed quantum coherence in microtubules is brief, nanoseconds, while neural activity lasts much longer. Without longer-lived quantum states, their impact on thought is uncertain. Consciousness itself is hard to measure. Subjective experience resists objective study. Even if quantum entanglement is found in the brain, linking it to conscious experience is difficult. The debate cycles, new evidence emerges, skeptics offer classical alternatives, and the stalemate continues. What's needed is an experiment that manipulates quantum states and directly alters consciousness. Only then can the quantum mind theory move beyond speculation. The search for the smoking gun continues. Proving the quantum mind demands new technology. Scientists are developing brain scanners to detect quantum signals, like microtubule resonances or entangled photons. Terahertz radiation may reveal quantum vibrations in real time, even through the skull. Early studies show electromagnetic signatures that correlate with consciousness, vanishing under anesthesia. If these signals match quantum predictions, it would be a breakthrough. The goals show quantum effects are not just present but functional in the brain. Experiments must prove these effects are orchestrated and used for computation. The journey is long, but each step brings us closer to understanding consciousness. Is the mind classical or quantum at its core? The answer could redefine what it means to be human. Proving consciousness is quantum would revolutionize medicine. Diagnosing and treating disorders of consciousness could become far more precise. Quantum biomarkers might reveal awareness in patients who appear unresponsive. Therapies could target quantum states, not just neural activity. Anesthesia could become safer, using methods that gently decohere quantum processes. Post-surgical recovery might improve by restoring quantum connections. Mental health could be reimagined. Disorders like depression might involve disrupted quantum coherence. New drugs or brain stimulation could retune the mind's quantum harmony. This perspective opens new frontiers for healing the brain. The quantum mind could transform our approach to consciousness and care. The implications of a quantum brain reach into the future of technology and artificial intelligence. For decades, we've mimicked the brain's classical functions to create artificial consciousness. But these models lack genuine subjective awareness. The quantum mind theory suggests we may have been building with the wrong tools. To create genuine AI, we might need to build artificial quantum intelligence. This would mean creating architectures that can sustain coherence in a complex environment. It would be a monumental feat, sparking brain-inspired quantum networks. These new forms of intelligence could potentially possess a form of awareness. They could explore vast possibility spaces, leading to breakthroughs we can currently only dream of. We would be on the cusp of creating not just a powerful tool, but a new form of conscious being. The quest for artificial consciousness would become a quest to understand the very fabric of our own minds. Perhaps the most profound implication of quantum consciousness is not medical or technological, but deeply personal and philosophical. The theory challenges the very foundation of who we think we are. We experience ourselves as singular, isolated beings, our consciousness locked firmly within the confines of our skulls. This sense of a separate self is the bedrock of our identity. But if our minds are entangled with the quantum fabric of the universe, this entire picture begins to dissolve. The boundary between me and not me becomes porous, perhaps even illusory, inviting us to see ourselves in a completely new light. If each moment of our awareness is a quantum event linked to the wider cosmos, then our individual consciousness is not truly individual at all. It is a localized expression of a universal process. We are not isolated islands of awareness adrift in a meaningless void. Instead, we are more like whirlpools in a vast cosmic ocean of consciousness, distinct yet inseparable from the whole. This perspective echoes the ancient wisdom of many spiritual traditions, which have long spoken of a universal consciousness, or a fundamental unity of all things. Science may be leading us back to a truth that mystics have known for millennia. This interconnectedness has staggering possibilities. If minds are linked through a universal quantum web, could there be subtle forms of communication we are not yet aware of? Could phenomena like intuition, empathy, or even shared moments of creative insight be faint whispers traveling along these entangled pathways? This doesn't necessarily mean telepathy in the science fiction sense, but a more fundamental underlying connection. Your thoughts, feelings, and memories might not be stored solely in your brain's neural patterns, but could be holographically entangled with the universe itself, leaving an indelible imprint on the fabric of reality. Ultimately, this journey into the quantum heart of the mind forces us to ask the biggest questions of all. What is the self? What is reality? And what is our place in the universe? If we are nodes in a cosmic quantum network, then every thought we think and every feeling we experience contributes to the whole. Our lives are not small, insignificant events. They are luminous strands being woven into the grand, interconnected tapestry of existence. The exploration of quantum consciousness is more than a scientific endeavor. It is a path to rediscovering our own profound and intimate connection to the entire cosmos. The implications of a quantum mind stretch far beyond biology, reaching into the deepest structures of the cosmos. Quantum entanglement, the engine of this theory, is not limited by distance. This opens a door to the possibility that our consciousness is intrinsically tied to the entire universe. Some theorists propose this cosmic connection is a mathematical reality. Every thought you have might be subtly linked to particles light years away. This paints a picture of a cosmic quantum web, connecting every point of consciousness to the universe. The universe may be living through us. Our minds could be local hotspots where the universal quantum field becomes complex enough to reflect upon itself. This challenges us to think beyond our individual existence. If consciousness is woven into a cosmic web, are we the only ones thinking? What if the ingredients for consciousness are properties of space-time itself? Perhaps awareness is a cosmic potential, and the universe has a tendency to wake up. The cosmos might be filled with minds, interconnected through quantum fabric. This echoes panpsychism, consciousness as a fundamental feature of reality. Everything possesses some form of experience. Our brains may be amplifiers of a consciousness already present in the universe. Our minds are part of a vast, interconnected quantum system. Could the universe possess a form of intelligence? Perhaps the most profound connection is through quantum entanglement. We may be part of a cosmic conversation without realizing it. This vision of a connected cosmos forces us to reconsider the very nature of ourselves. If our consciousness is part of a universal quantum fabric, what happens to a thought when it fades? What happens to a memory when we forget? In a quantum model, the information might never truly be lost. Think of it like a ripple on a pond. Similarly, every conscious moment could be a ripple in the cosmic quantum field, echoing through eternity. Our minds would contribute to the cumulative memory of the universe. The quality of our consciousness could be our contribution to this universal tapestry. We are actively shaping reality with the very nature of our awareness. Are we isolated biological machines, or are we luminous threads in an infinite interconnected cosmos? We have journeyed from the vastness of the cosmos to the intimate corridors of the human brain. We have explored a reality where the line between mind and matter begins to dissolve. The possibility that consciousness arises from quantum mechanics is a profound reevaluation of ourselves and our place in the universe. For centuries, we have looked to the stars as the final frontier. But perhaps the greatest frontier is not out there, but in here, inside our own minds. The quest to understand consciousness is the ultimate exploration. If quantum theorists are right, then this inner universe is inextricably linked to the outer one. This grand hypothesis that our minds are quantum machines entangled with the cosmos is still in its infancy. We are being forced to accept that nature's ingenuity may be far greater than we ever imagined. We are asking if the universe itself can think and feel and be aware through us. So, what are we? Are we simply biological machines or something more? Is our consciousness part of a vast cosmic quantum conversation? Every thought, every moment of awareness is a ripple in an infinite tapestry. It suggests our existence is a meaningful part of a much larger, interconnected whole. It transforms us from lonely observers into essential participants. The journey into the quantum roots of consciousness promises to be revolutionary. It seeks to understand the very nature of the explorer. We may see the universe as a vibrant, living system. Every feeling is a luminous strand in this grand, interconnected cosmos. This is the ultimate promise of this scientific revolution. It is a profound exploration of our place in this vast, mysterious universe.
If you enjoyed this video, give it a like, share it with your friends, and subscribe so you don't miss out on future ideas that challenge us to think outside the box. We'd love to hear your thoughts in the comments below. Until next time, and don't forget to always maintain that curiosity that drives progress. Also, explore even more fascinating content on our channel. From life-changing tips and cutting-edge technology, to the mysteries of spirituality, travel to various countries, delicious recipes, health hacks, and language learning, there's something here to spark your curiosity and elevate your life. Dive in and discover a world of knowledge awaits us.